Hi, welcome back to class. Hello. Hi, hello. Good to see you again. We're doing two sections up today. We're doing 7.1 and 7.2. Let's kick it off with 7.1. We're talking ratios and proportions. You've seen ratios before. These are just fractions. Yeah, you can groan now. Everyone hates fractions. Remember, huh? Especially you guys. A ratio is a comparison of two quantities using division. So it's just division, and we can write these ratios in three different ways. We can write it as one of the numbers, the word 2, and then the second number. Or you can write it as the first number, a colon, and then the second number. Or you can write it as the fraction, number over number. In all of these cases, that second number is the one that you're dividing by, and so it cannot be 0. Otherwise, we break math. We use ratios in things called aspect ratios. That's like the ratio of this YouTube screen that you'd be watching this on later. Or if you're watching it in the recording, it's the width of the screen divided by the height of the screen. Okay, so this aspect ratio 32 to 18 is the same as 16 to 9, because if I were to write 32 to 18 as a fraction, I'd end up with a fraction 32 over 18, which then if I think about common factors, the fact that they're both even, which means I can divide by 2, I divide out those common factors and I get 16 over 9. In our skill practice, the first 5 questions, so skill practice questions 1 through 5, come from this real world example number 1, coming to us from sports. So let's read through this particular word problem. From the world of sports, it says, baseball players' batting average is the ratio of, okay, let's get some highlighting going so we can see what we're taking the ratio of. The number of base hits, here's the word 2, and then the number of at-bats. And this is where I had to pause, because when I first read this one, I was like, at-bats, what is an at-bat? What is a bat? And so I went to Google and I was like, hey, Google, what's an at-bat? And Google told me that an at-bat is the number of times that you go up to the plate or whatever it's called, and you hold the bat and they throw the ball at you and you try to hit it. It's not just the number of times that you hit. That's the base hits. That's the number of hits. And it's not how many times you miss. It's how many times you stand there and give it a try, even if you don't swing the bat. If they threw the ball at your general direction while you're standing there holding the bat, it was an at-bat. And so we've got this table here that talks about the number of at-bats and the number of hits that this dude, Ian Kessler, managed in his career. And as I keep reading the word problem, I find out that they want to know what his batting average is. That's over the total life of his career. Now notice the way that I highlighted the number of base hits first. And so that's going in the numerator of my fraction. The number of at-bats then is the denominator, the number I'm dividing by. Looking at my chart, I find my at-bats, I find my hits, and I'm going to take the number at the very bottom because they want his total batting average. So I'm looking at those two there, put them in the right order, and then do some division. Anytime that we create a ratio with a denominator of 0, it's called the unit ratio. And so his batting average as a unit ratio is 0.273. And I have no idea if that's good or not. So I don't know if he's a good player. If I had batting averages of a whole bunch of players, I would then assume the ones with the highest batting average are the best players. And so if I were trying to build a team that could give me the most wins, then conceivably I would just pick all the ones with the best batting average and I would have an awesome team. So questions 1 through 5 on your skill practice, which looks something like this, gives you a bunch of different scenarios with a bunch of different word problems and asking you to create ratios of one thing to another thing. Questions? I'm looking at the chat to see if my chat is giving me questions. And looking around the room to see if there's any questions. No hands going up. Okay, cool. Let's talk about the next thing that might be new to you, because that was probably something you've done before. The new thing is this thing called extended ratios. This is going to help you on your skill practice questions 12 through 15 to the very bottom. Now, what an extended ratio is when you've got more than 2 numbers in your ratio. So this ratio that I've highlighted in green says 3 to 4 to 5. And so this word problem says the ratio of the measures of the angles in a triangle is 3 to 4 to 5. Find the measures of the angles. Well, if we were looking at just the ratio of the first two, 3 to 4, we can think of it as 3x divided by 4x. This x is helping us figure out what we need to multiply each of these pieces by in order to get the actual measure of the actual triangle that we have sitting there. And so if I think of each of these as that ratio number times some value x, I can then write an equation to help me solve for the measure of each angle. Because I'm being asked for the measures of the angles in this case, I need to go to my triangle angle sum, where I remember that if I were to add the measures of all the triangles, I would get to 180. A quick sketch of the situation allows me to see that I have an angle here and here and here, and that if I add them, 3x plus 4x plus 5x, I'd get to 180. Adding up the 3, the 4, and the 5, I get to 12. And when I divide both sides by 12, x equals 15. But I wasn't asked for the value of x. I was asked for the measure of the angles. So I have to come back into here and multiply the x by whatever number I had in front. So in this case, 3 times 15 is 45. In this other angle, 4 times 15 is 60. And in this final angle, 5 times x is 75. And so here are the 3 different angles of this triangle. The skill practice, however, not going to be this simple because they want to know the perimeter. But with an extended ratio, the process remains the same. This says in a triangle, the ratio of the measures of the sides is 2 to 2 to 3, and that the perimeter is 392 inches. Well, remember with this extended ratio, I can rewrite them to think about them as the measure of the actual sides. In this case, 2x to 2x to 3x. And perimeter means add all the sides together. So I'm going to add these measures because these are the measures of the sides. So 2x plus 2x plus 3x equals the perimeter of 392 inches. And that's given to me in my word problem right here. Same process as before. I'm going to add these coefficients. 2 plus 2 plus 3 is 7. Which means that x is whatever I get when I take 392 and divide it by 7. Someone help. I see calculators. I love it. 56. And then I'm going to go back to my word problem and read the last sentence to see what I was asked to find. In this case, I was asked to find the length of the longest side. That is the one with the largest ratio piece. And so the measure of the side is whatever I get when I take 3 and multiply it by 56, which in this case is 168. Please be careful when you're reading the word problems to make sure you know which sides they want you to do. Some of the questions may ask for the longest side like this one does. Some may ask for the shortest. Some may ask for all. Just make sure that you're reading very carefully to know which sides you want, because that's going to determine how many points I can give you for the question. Questions? Looking at the chat. No comments yet. Looking around the room for hands. Sure. Up, sure. You're welcome. Scrolling up because people are writing physical notes in class. I love it. All right, can I scroll down? Cool. All right. Now you notice that I missed a huge chunk of the skill practice. I didn't tell you how to do questions 6 through 11. So let's do that now. It's called using the properties of proportions. And one of the biggest properties that we have is this thing called the cross products property. All of you, I'd imagine, are already very familiar with how to use this property. But let's talk about what all these words are first. First, we need to know the definition of a proportion. A proportion is an equation where two ratios are equal. That is, it's an equation with fractions where all you have is one fraction equal another fraction. That's a proportion. We have different parts of this. We have the extremes, which are going to be the numerator of one and the denominator of the other. And then the means, which are the denominator of one and the numerator of the other. But we use this so that way we can talk about multiplying the extremes and multiplying the means. And when we do that, we get something called the cross product. The cross product property then says that if we have a proportion that is one fraction equal to another fraction, then we can cross multiply. And that's where cross multiply and solve comes from, is this cross product property. Please note that we have things that cannot be zero. Okay, those denominators cannot be zero, otherwise this doesn't work. Let's remind you how to use the cross products property to cross multiply and solve. And these are going to be your skill practice questions 6 through 11 on worksheet 7-1. I'm going to talk through question A, and then I'd like to work through 3C with you in this space. All right, let's look at letter A. Here's my proportion where I have 6 over x equals 21 over 31.5. What we've done here is we've identified the extremes, that is the numerator on one side, the denominator of the other. And then we've identified the means, that is the denominator on one side, the numerator on the other. And we've multiplied those together. Now that we have them multiplied, we can simplify. This is 6 times 31.5, and this is 21 times x. Then we divide both sides by 21 to reveal that x is 9. So when asked to solve the proportion, you're just trying to figure out what the value of x is. Let's do 3C together the exact same way, except it's going to look different because now we have 2 of the variables and it looks like it's going to be more complicated. It starts the same way. Identify extremes, and we're going to write those down first and multiply them together. I'm going to write them here. And then identify the means. We're going to multiply those together and we're going to write them down. And they're equal to each other. So my extremes are 7 times the group z plus 4. And my means are 9 times the group z minus 1. Really important. I really want to see you working on this skill. That is the cross multiply and solve. Because when you hit algebra 2, there's an entire section where you have to do this and the fractions look crazy. There's very few numbers involved. Okay, so I want you to remember that anytime you have one fraction equal one fraction, you can always do this cross multiply thing. All right, I'm going to wait for questions in the chat and in real life while I work on distributing this out and solving for Z. I apologize now if my handwriting goes crazy because I look off to somewhere else. Oh. Oh. I had a fatal flaw. 7 times 4 is not 4. 7 times 4 is 28. Why did no one catch that? It's because you're not paying attention. You're all asleep. Okay, I had a laugh. That means you're awake enough to listen to my horrible jokes. And then when I get to this spot, it's easy for you to see that if I were to divide both sides by 2, your answer would become 37 divided by 2. Please practice the cross multiply and solve. Even if you can think through in your head very quickly some of the numbers, especially if they're small, or if you're like, okay, I know what I'm supposed to do, I'm just going to multiply and divide, and you do it on the calculator really fast. Please avoid doing that. I really want you to practice writing it down with the cross multiplication. It'll save your life as you move on to algebra 2 and into pre-cal and calculus and beyond. If there are no questions, cool. Let's use these proportions on similar polygons. So going into section 7.2, where we're talking about similar polygons, notice in our objective, we're going to be solving problems with those similar polygons, and we're doing that by writing proportions. So we're back to the whole proportion thing, and the skill that we just learned how to do definitely coming into play here. But first, let's figure out what a similar polygon even is. A similar polygon or polygons are going to have the same shape, but they're not necessarily going to have the same size. So one might be really itty bitty and the other one might be really, really big. Polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So important here that you remember how to calculate angle measures inside of a shape. If you're looking at triangles, you're going to triangle angle sum, add them up, they equal to 180. You might also be using that third angles theorem. If you know that 2 of the other angles are congruent, you get the third pair of angles congruent for free. If you've got a quadrilateral or any other shape, a number of shape of figure, a hexagon or octagon or thing, something weird like what was the one that we found last semester that was 69 sides, 420 sides? I forgot what it's called too. It was written on the board and it was really long and really cool. Tell you what, when this video goes to YouTube, or if you're watching on YouTube, go find the names of those, drop them in the comment below. We'll all have a good laugh. That'll be fun. But anyway, remembering that you can use the polygon angle sum to help you know how to add up all of those angle measures in there. So as you're deciding if things are similar, you need to first check to make sure that all of your corresponding angles are congruent, and then that your corresponding sides are proportional. That is, when you create fractions with the lengths of those sides, that those corresponding sides are going to give you the same fraction each and every single time. If you get that, then you can state that they are similar. And here's the symbol for similar. It is the squiggle from the congruent sign, but without the equal sign underneath. Because we don't have all equal measures everywhere. Only the angles are equal measures. Got it? All right, let's practice how to determine if triangles are similar. All right, This says determine whether triangles are similar. If they are, write the similarity statement. That is, write this thing, similarity statement. And the scale factor. So let's take a moment. Let's talk scale factor really quickly. The scale factor is just that fraction you get when you write the side lengths in ratios. But the scale factor is going to depend on the order that you're making your comparison. If we take a look at this diagram saying that these two triangles are similar, if we state the scale factor as ABC to XYZ, those are the names of the triangles, then our scale factor becomes 6/3. That is, here's the information from triangle ABC, and here's the information from triangle XYZ. Where if we write the scale factor in the other order, if we compare them XYZ to ABC, notice that now the numbers are flipped. The first number in your ratio is always the numerator of the fraction. So when we're doing this setup down here, which we're about to do in a second, when we write these scale factors, we have to make sure that we're going to compare them in the same order. Otherwise, we're going to get two different scale factors, and we're going to say that these are not similar when in fact they are. Okay, keeping that in mind, let's take a look. Here's angle N. I've already colored it in yellow for us. It's congruent to angle R, so those must be corresponding. Q is congruent to S. They both have the same number of little arcs. But P, I don't have any information about P. However, because I have two pair of congruent angles already showing, with my third angles theorem, I get the third pair of angles for free. P and T must be congruent, and so they're corresponding. Checked off on the corresponding angles being congruent. Let's check if the sides are in proportion. That is, I need to write the side lengths as fractions and hope I get the same fraction each and every single time. All right, I'm going to do yellow to green first. That's N to Q. I'm going to write it way over here so I have plenty of room. NQ, and I'm going to write as a fraction over its corresponding side on my other triangle. This was yellow to green, so I'm going to find the yellow to green side. Note, I'm using those colors to help make it easy for us to identify what corner I'm talking about. You're welcome to color coordinate your homework, your notes. Someone in the room is going, this, I was waiting for this day. Dealing with fractions when they have decimals is a nightmare. So I'm gonna use my calculator, and I'm just gonna turn these scale factors into decimals, and I'm gonna be okay with that. 12.5 divided by 10 is 1.25. I've now checked these sides. I'm going to check the other two sides in quick succession. Feel free to ask questions as I'm doing this so that we can see if these side lengths are in proportion. I'm doing the pink and green side right now. Notice I'm being careful with the order that I'm writing them on, because in the very first scale factor that I found, I wrote the information for the triangle on the left on top, and I wrote the information for the triangle on the right on bottom. I need to follow that exact same order when I'm doing all the rest of these. Otherwise, I may get an incorrect scale factor somewhere. All right, last but not least, the yellow to pink side. NP, RT. This is 15. This is 12. Going to my calculator, 15 divided by 12. And all of my scale factors are the same. All of my ratios are the same, which means they're in proportion, which means that's my scale factor. I can abbreviate that as SF if I want to. My scale factor is 1.25. All right, time for me to write my similarity statements. I'm going to write the name of this triangle on the left first. Order that I decide to put these letters in, not important. Can put these in any order I want. I need to use the symbol for similar. Remember, it's just the little tilde squiggle that we normally put on top of the equal sign to make it mean congruent. I'm going to write the symbol for my second triangle, and now the order in which I write the triangle's name becomes important. I wrote the letter N first. The letter N in this triangle I colored yellow. So I need the letter that I colored yellow in my second triangle. That's R. I wrote P next. P was pink. T is pink, so T comes next. And last is Q. Q is colored green. My other triangle, S, is colored green. There it is. I have written my similarity statement. And this is how you do skill practice questions 1 and 2 for section 7.2. Questions? I see nothing in the chat. Looking for hands in the room. Nothing. I had some shakes of the head. Awesome. All right, let's do the rest of the page. The rest of the page is going to be done exactly like here in example 3. So skill practice questions 3 through 6 are all going to be done this way. I would like to work on 3A with you. I'm going to use these 2 items down here. So I need to find the value of each variable if these 2 triangles, triangle JLM and triangle QST, are similar. The first thing I'm going to do is I'm going to figure out which corners are corresponding. J and Q were both written first, and so they are corresponding. I'm going to color them both in the same color. L is second place, as is S, so I'm going to color those in the same color, but different from J and Q. And I'm going to do the same thing with the very last letter, that's M and T. And so now M and T have their own color. And now it's really easy for me to see which corner corresponds to which corner. Trying to find the value of X. So as I look at my diagram, my very blurry diagram, again, my apologies for it being so super blurry. I'm going to zoom in a little bit better. Not that that helps, it's super pixelated. Yikes. Okay, here's X right here. This says 6X minus 3. So this side I definitely want in my proportion. So I'm going to start off my proportion with LM. Now I need to find the corresponding side on the other triangle to pair it with. LM goes from green to blue, so I want the side that goes from green to blue. That side's name is ST. Now I'm going to write it as a proportion, which means I need to set this fraction equal to another fraction, and that fraction is created by 2 sides from both of these triangles. I get to pick any other sides I want. I just want to make sure I pick ones that are the most useful to me. If I look at this side J to L, I notice it has a variable in it. That's not helpful to me right now because I don't know what the value of Y is. So I'm not going to pick this one for the moment. And I'm not going to pick his partner either. So yellow to green side is out. Yellow to green, this side is out, which means the only one left is this yellow to blue side. Notice in my first ratio, I wrote the triangle on the left information on top. So I'm going to write the triangle on the left information on the top again. So JM in the top of my second fraction. Yellow to blue on the second triangle is Q to T, and there's the proportion that I'm interested in working with. I'm going to go ahead and substitute. While I'm substituting, if you've got a question, please feel free to hit me up in the live chat here on Zoom, or raise your hands if you're in the live studio audience in class. Please let me know if you've got any questions. I apologize for my handwriting if it becomes horrible. No questions. And you notice how now this looks exactly like the very last example we did in the previous section? it gets solved the exact same way. So go back and refer to section 7.1 for how to do the rest of these. Yes, sir. I crossed out 3y minus 2 here because for this particular equation, this one wasn't helpful because it had a value of y in it, and that wasn't going to help me solve for x right now. Once I'm done, I can bring this back and be like, okay, now I want to find the value of y, which is the next item. And so now I'm going to use this side's information. You're very welcome. That's a great question. Any other wonderful questions? Okay. Then the thing to end on is what to do when we're talking perimeters. And this is our very first theorem for the chapter. This is theorem 7.1. And it says that if you know that two polygons are similar, then the perimeters are going to be proportional to the scale factor. So if you can find the scale factor of your two polygons, that is, grab some side lengths, make them a fraction, then the perimeters of those two polygons are going to be the same sort of fraction. So the same way you set up a proportion here, you can set up a proportion where one side is the perimeters and the other side is one of the side lengths. That's it. Awesome. Well, if there's no other questions, please feel free to give me a like and a subscribe. I'm going to do an epic on-screen hair reveal. How long has my hair grown? It's almost always up in a bun. We'll see that. We're trying to hit 300 subscribers. If you're in class this year, please ring the bell so that way you know when I've uploaded your lecture video, it'll alert you so you can go back and rewatch it, especially if you're at home doing your homework and you're like, gosh, I don't remember how to do this. You'll know when that video is up, you know, you go back and rewatch it. Don't forget to leave me a comment with a timestamp of anything that was important to you. I'll grab those timestamps, stick them in the description and make it easy for you to find later. Thank you very much. Have a wonderful day. Thanks for coming to class and we'll see you next time. Applause today. I'm so happy. Thank you.